welcome back. This is Mrs. Rewright with Algebra 1 Honors. Today's lesson is 10.4, Misleading Graphs and Statistics. Alright guys, so which statistics are most affected by outliers and what shapes can data distributions have? So that's what we're going to be exploring today. So we're going to use line plots to display data. 12 employees at a small company make the following annual salaries in thousands of dollars. Create a line plot of the data, putting an X above the number line to represent each data value. Stack the X's for repeated data values for people who earn the same amount. So we have someone earning $25,000. We have someone earning $30,000. We have someone earning $35,000. There's 1, 2, 3 people earning $35,000. There's 1, 2, 3 people earning $40,000. And we have 2 people earning $45,000 a year, 1 person earning $50,000 a year, and 1 person earning $60,000 a year. Okay? Complete the table round to the nearest hundredth if necessary. So what is our mean? Our mean is our average. So we need to add up all the numbers and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So, yes? Yes. All right, so we're going to do 25 plus 30 plus 35 plus 35 plus 35 plus 40 plus 40 plus 40 plus 45 plus 45 plus 50 plus 60 divided by 12, and we get that their average is $40,000. The median is the number in the middle. So we go 1 for 1, 1 for 1, 1 for 1, 1 for 1, 1 for 1. We average the two in the middle, and they average to 40. I'm able to do that because they're listed from least to greatest. Your range, your highest number minus your lowest number, 60 minus 25, is going to give us 35. It has a range of 35. Our interquartile range. So we need to, basically, if I was making this into a box and whisker plot, I would have a point at 25, right? I would have a point at, let's see, I'm going up to 60, so maybe 25, 30, 35, 40, 45, 50, 55, 60. So here's my line graph. So I have a point at 25, I have a point at 60. My midpoint, we said, was 40. The midpoint of the lower half, average these two and you average to 35. The midpoint of the upper half is 45. So we have 35 and 45. Here's my box. Here's my whiskers. My interquartile range is the range in here of my box. It's 45 minus 35. 45 minus 35 is 10. Okay? And my standard deviation, how do I get my standard deviation, guys? Do you guys remember that one? Well, it's going to be 8.90. You can get it from your graphing calculator, but you can also get it using the formula, which is, hold on one second. All right, so we're quickly going to do this. I know that we don't have a graphing calculator, so we have to do it the annoying way. But we're going to get our standard deviation. So we take the data point minus the average, minus the mean, and we square that. The data point minus the mean and square it. The data point minus the mean and square it. 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 Data point minus the mean, 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 square it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which we're supposed to have 12 things, so we're good. All right, so 25 minus 40 squared, 30 minus 40 squared. I didn't do that right. 25 minus 40 is negative 15. Squared is 225. Sorry, I must have forgot to press the equal sign. 30 minus 40, negative 10, squared is 100. 35 minus 40 is negative 5. Squared is 25. 25, 25. 40 minus 40 is 0. 0 squared is 0. 5 squared is 25. 10 squared is 100. 20 squared is 400. Now I'm going to take all of these answers, I'm going to add them up and divide by 12. So 400 plus 100 plus 25 plus 25 plus 25 plus 25 plus 25 plus 100 plus 225. I got 950 divided by 12. Did you guys get to the 950 divided by 12 yet in your calculator? Did you add up all this and get 950 divided by 12? Did you get 79.16? Take the square root, and you get 8.89756, which is 8.9. So, to get the standard deviation without a graphing calculator, it is annoying. You take each data point minus the average, square it, record all that, and then you're going to take the average of all that, and then you're going to take the square root of the average of the deviation, the squared deviation. So it's like the square root of the average of the squared deviation is your standard deviation. It takes into account every single data point, including outliers. All right. Quantitative data are numbers such as counts or measurements. Qualitative data are categories such as attributes or preferences. For example, employees' salaries are quantitative, while employees' positions within a company are qualitative. Do you guys get that? Quantitative numbers, qualitative not numbers, like things, right? Job titles. It is appropriate to use a line plot for displaying quantitative data, qualitative data, or both. Explain. When would you use a line plot? Quantitative or qualitative or both? What? Yeah, quantitative data. A line plot uses a number line. So it is appropriate only for displaying quantitative data. The line plot allows you to see how the data are distributed. Describe the overall shape of the distribution of employees' salaries. What do you guys think? What's the overall distribution? Isn't it more like kind of like a bell-shaped curve? Doesn't it look kind of like a bell-shaped curve where it's mounded in the middle? So very few people make lower amounts or higher amounts. You guys kind of have like an outlier that's significantly higher and an outlier that's significantly lower. And then most of the people make around the same. So the distribution is mounded near the center and trails off at the ends. When you examine the line plot, do any values appear to be different than the others? Explain. The data value 60 appears separated from the other data values, right? Kind of feels like it's an outlier. Someone's making a lot more than everybody else. Maybe they're the boss, right? Recall that an outlier is a value in a data set that is relatively much greater or much less than most of the other values in the data set, and you can determine whether a data value is an outlier by using the following rule. A data value x is an outlier if x is less than quartile 1 minus 1.5 of the interquartile range, or if x is greater than quartile 3 plus 1.5 of the interquartile range. Okay? Investigating the effect of an outlier in a data set. Suppose the list of salaries in the previous example is expanded to include the owner's salary, which is $150,000. Now the list of salaries is 25, 30, 35, 35, 35, 40, 40, 40, 45, 45, 50, 60, 150. They are definitely an outlier. Create the line plot for the revised data set. Choose the approximate scale for the number line. So I'm going to go by fives, I guess. Or no. I'm not going to be able to go by fives because I won't be able to get up to 150. All right, let's do this. 20. I can go by fives. 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130, 135, 140, 145, 150, 155, 160. Okay. So, let's see. We've got 25, 30, 35, 35, 35, 40, 40, 40, 45, 45, 50, 60, 150, 145, 150. Complete the table, use a calculator, and round to the nearest hundredth if necessary. So what is my mean, my average? So I have 25 plus 30 plus 35 plus 35 plus 35 plus 40 plus 40 plus 40 plus 45 plus 45 plus 50 plus 60 plus 150 equals divided by 13, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now I got 48.46, so we're going to put that down. 48.46, our median, our number in the middle. In the middle. Why don't you just meet me in the middle? I'm losing my mind just a little. 40. My range, I'm going from 150 to 25, so 150 minus 25 is 125. My interquartile range, so I have, this one's the middle, right? So I have to find this, and I have to find this. So 1 for 1, 1 for 1, 47.5. When I take 45 plus 50 divided by 2. 1 for 1, 1 for 1. Average these two, I get 35. So 47.5 minus 35. That's 12.5. My standard deviation. That's so fun. Oh my goodness gracious, we get to do it again. All right, this is so fun. Okay, so 25 minus, do you guys see my sarcasm? 48.46 squared. 30 minus 48.46 squared. 35 minus 48.46 squared. 35 minus 48.46 squared. 35 minus 48.46 squared. 40 minus 48.46 squared. 40 minus 48.46 squared. 40 minus 48.46 squared. 45, 45, 50, 60, 150. All right. 48.46 negative plus 25 equals squared. $30 minus 48.46 equals squared. $35 minus 48.46 equals squared. Okay, so I added all of this up, and I'm going to divide that by 13, and then take the square root. Divided by 13, and then take the square root. And I got, did I take the square root first? No, I didn't take it yet. Okay. 30.53. 30.53. So I'm going to write that here. A lot of work, right? Each number minus the average squared. You square the difference of the mean. And then you average them, and then you take the square root. You average their squared differences, and then take their square root. All right, so complete each sentence by stating whether the statistic increased, decreased, or stayed the same when the data value of 150 was added to the original data set. If the statistics increased or decreased, say by what amount. All right, so the mean. What was the mean? The mean was 40. Now it's 48.46. What did it do? It increased by 8.46. The median. Your median was 40. Now it's 40. It stayed the same. The range. The range was 35. Now it's 125. It increased by 90. The interquartile range, it was 10, now it's 12.5. It increased by 2.5. So do you guys see how the interquartile range is going to have less of a difference when it comes to outliers than the range? The full range includes outliers, where the interquartile range doesn't really acknowledge the outliers. The outliers aren't going to affect it like it affects the total range. That's why it's kind of like an important piece of the statistics. The standard deviation, it increased by 21.63. Show how the data value of 150 is an outlier, but the data value of 60 is not. Use the inequalities given at the top of the previous page to support your answer. So, what inequality did they give you at the previous page? They told you what? For either data value to be an outlier, they would have to be greater than Q3 plus 1.5 times the interquartile range. So we'd have 47.5 plus 1.5 times 12.5. That's 66.25. So 150 is an outlier, but 60 is not. Q3, right? What is my Q3? My Q3 was 47.5. 47.5 plus 1.5 on my interquartile range of 12.5. When I do that, I get 66.25. So 60 is not bigger than that, but 150 is, and that's how we know that that is an outlier. What effect does the outlier have on the overall shape of distribution? It lengthens it, right? The tail to the right of the distribution center. Is this stuff making sense to you guys? Yeah? Your homework tonight, because we are running out of time, your homework tonight is on page 581 and 582. I know you guys are going to hate the standard deviation parts, but luckily it looks like there's only, let's see, on your homework, you have to do quite a few. Sorry. But the good news is you only have homework on 10.4, which is on 581, 582, as well as your textbook, the quiz review. You have 2 more questions left on the quiz review, question 9 and 10 on page 725 in your textbook, and to study for your quiz, which is tomorrow. All right, I hope you guys enjoyed the lesson. Please like and subscribe and have a fantastic